The Earth feels solid, permanent, unchanging. Every day, billions of people walk across its surface believing the ground beneath them is stable. But deep below our feet, the planet is constantly moving. Massive pieces of Earth's crust drift slowly across the globe. They move so slowly that we rarely notice. Yet when these enormous forces are suddenly released, the results can be catastrophic. Buildings collapse, roads split apart, mountains shift, entire cities can be changed in a matter of seconds. This is the story of earthquakes, one of nature's most powerful and unpredictable forces, a force capable of reshaping the world in a single moment. To understand earthquakes, we must first journey beneath the Earth's surface. The planet is made of layers. At the center lies a superheated core. Above it is the mantle, a vast ocean of slowly moving rock. Floating on top is the crust. But the crust is not one solid piece. It is broken into giant sections called tectonic plates. These plates are constantly moving. Some move apart, some collide, others slide past one another. Most of the time, the movement is slow, only a few centimeters each year. But over decades, centuries, and millennia, enormous pressure builds. Eventually, the rocks can no longer withstand the stress. They break. The stored energy is released, and the Earth shakes. An earthquake has begun. Every earthquake starts at a point underground called the focus. Directly above it on the surface is the epicenter. When rocks break deep beneath the ground, energy travels outward in waves. These seismic waves spread through the Earth in every direction. Some waves move quickly through solid rock. Others travel along the surface. These surface waves are often the most destructive. The strength of an earthquake is measured using magnitude scales. Each increase in magnitude represents a dramatic increase in energy. A magnitude 7 earthquake releases far more energy than a magnitude 6. A magnitude 8 can release more energy than hundreds of atomic bombs. Yet, the true impact depends on more than magnitude alone. Depth, location, population density, building quality, all play critical roles. May 23, 1960. In southern Chile, the Earth unleashes unprecedented power. A magnitude 9.5 earthquake strikes. It remains the largest earthquake ever recorded. The shaking lasts for minutes. Entire communities are devastated. But the destruction does not end there. The earthquake triggers a massive tsunami. Waves race across the Pacific Ocean. Hours later, coastlines thousands of kilometers away are struck. The disaster demonstrates a terrifying reality. An earthquake in one part of the world can affect nations on the other side of the ocean. 26 December 2004. Beneath the Indian Ocean, near the coast of Indonesia, a gigantic earthquake occurs. The seafloor suddenly rises. Billions of tons of water are displaced. A tsunami is born. The waves travel across the ocean at jet aircraft speeds. Many coastal communities have no warning. Minutes later, walls of water crash ashore. The devastation is unimaginable. Countries across Asia and Africa are affected. More than 200,000 people lose their lives. The disaster becomes one of the deadliest natural catastrophes in modern history. In its aftermath, nations work together to improve tsunami warning systems. A lesson learned through tragedy. The 11th of March 2011. Off the coast of Japan, powerful tectonic forces suddenly release. A magnitude 9 earthquake strikes. The shaking is intense. But once again, the greatest danger comes from the sea. A massive tsunami races toward the Japanese coastline. Entire towns are overwhelmed. Ships are carried inland. Buildings are swept away. The disaster also triggers a crisis at the Fukushima Daiichi nuclear power plant. The event becomes one of the most studied natural disasters in history. It highlights both the power of nature and the importance of disaster preparedness. Earthquakes are not distributed evenly across the planet. Most occur near tectonic plate boundaries. One of the most active regions is the Pacific Ring of Fire. Stretching around the Pacific Ocean, it contains many of the world's most active faults and volcanoes. Countries such as Japan, Chile, Indonesia, and New Zealand experience frequent seismic activity. But earthquakes can also occur far from plate boundaries. Ancient faults hidden beneath continents can awaken unexpectedly. No place is entirely immune. For centuries, humanity has tried to predict earthquakes. Scientists monitor faults, track seismic activity, measure tiny movements in the Earth's crust, observe changes in groundwater and gas emissions. Yet predicting the exact time and location of an earthquake remains one of science's greatest challenges. Today, researchers focus on early warning systems. These systems can detect the first seismic waves and provide seconds of warning before stronger shaking arrives. Those few seconds can save lives, stop trains, shut down industrial systems, and give people time to seek shelter. Modern engineering has transformed earthquake safety. Skyscrapers can sway without collapsing. Bridges are designed to flex during shaking. Buildings use shock absorbers and base isolation systems. In earthquake-prone countries, strict construction standards help reduce damage. The goal is simple: not to stop earthquakes, but to survive them. Every lesson learned from past disasters improves future safety. Behind every earthquake statistic is a human story. Families searching for loved ones, rescue teams working through the night, communities rebuilding from ruins. Acts of courage emerge in the darkest moments. Neighbors helping neighbors, strangers becoming heroes. Even after immense destruction, people rebuild. Cities rise again. Life returns. Hope survives. At this very moment, tectonic plates continue to move beneath our feet. Pressure continues to build along faults around the world. Somewhere, the next earthquake is already forming. It may happen tomorrow, next year, or centuries from now. No one knows. But one thing is certain: earthquakes are not signs that the planet is broken. They are signs that the planet is alive. A reminder that our world is constantly changing, and that beneath the ground we stand on lies a force powerful enough to reshape history itself.